Hi, I'm Ron Lindsay, Senior Product Manager for Amphenol, and I wanted to talk to you today about putting optical passives into outside plant enclosures. Okay, so what you can see here is we have an outside plant enclosure. In this case, it's a CommScope FOSS closure. This is the D. And what we're going to show you is putting our muxes into this enclosure, high channel count muxes, as well as lower channel count muxes. So the first product to explain here on the top is our optical mux for higher channel counts. So this can go up to 20 channel, 40 channel, up to 48 channel mux would be in this larger package. We call it the OSP AOM. And so a couple of key features we'd like to point out, and the first one is the test ports. So historically, the industry puts the test ports on the end of an optical fiber, so there'll be a pigtail with a connector on the end. That needs to be stored somewhere in the splice enclosure and then pulled out when the field technician is ready to test the network. And we've done it that way historically as well, but the innovation for this product is we came up with putting that feature set in an adapter. So as you can see here on the end, there's two adapters. One's testing in the receive direction, one's testing in the transmit direction, and you simply just pop a dust cap, insert your test connector, test the network, put your dust cap back in, and it saves a ton of time in the field for the field technician to simply gain access to that test port, which is opposite the hinge, instead of trying to fish out a connector, find that connector, test, and then put the connector back. So that's the first innovation to share. The second one is a lot of good labeling and fiber identification. So we know how important it is for the field techs to have efficient use of their time. So what you'll see here is coming off of the back of the OSP AOM, there's tubes that contain, color-coded tubes that contain color-coded optical fibers. So those fibers are then routed to the splice tray for splicing. And then on each of those fibers, in addition to be color-coded, there's an identification ring. The ring can move around, so you can slide it out of your way, but that ring also provides the identification for the wavelength or the fiber. It could be the common port, express, upgrade, DWDM wavelength, what have you. So it gives you multiple ways to identify the fiber and ensure the field techs know which one needs to be spliced in that particular job. So that's the larger channel. And what you'll see here is this whole demonstration is being done with the CommScope FOSS closure. So this is the FOSS D. It can also fit in the FOSS B. We fit in PLP closures, AFL Apex, Amphenol Charles. We're using this as an example to show you how they're fitting into this particular closure, but the same principles and slightly different adapters are used to go into lots of other field enclosures as well. So our smaller channel count mux, we call the high DT. And this small blue package you can see is quite compact. We can actually put 6 of these muxes on the CommScope D tray compared to the industry standard of only 4. So that's a 50% density increase that we can leverage with this small package. And this package also has some innovative features of all the fibers coming out one side. So it really simplifies fiber routing, helps eliminate the need for crossovers, which you can still do, but again, just that convenience of having a simplified process for the field craft to get this spliced into the network. So again, labeling all the ports, color-coded fibers for the ports, and then again, if we go down to the tray below, multiple locations where the fiber identification rings are located. So again, DWDM channel might be there, it might say express port, upgrade port, what have you. The other unique piece is we can fit both of our mux styles into the slack basket. So in this case, the slack basket is where we store our buffer tube slack. There's 2 positions in the tray tower that typically go unused. In this case, we can make use of those because our muxes are so small. So as you can see, this larger OSP AOM, so this could be up to a 48 channel mux, nests into the slack basket in one of our tray tower positions. And again, we would just route from there up to a splice tray for splicing. Our smaller mux also fits in this space, and you can fit on our splice tray up to 2 muxes on the tray, and then this tray fits down in the slack basket as well. And again, it just allows you to leverage that space in your network. The investment of this enclosure can be fully utilized with these types of features. If you have an urban environment where you have a lot of density requirements, it's a really nice thing to take advantage of this slack basket space, which typically does go unused.